So what happens? This formation of these focal adhesions complexes, it activates so-called intracellular, once again, signal transduction cascades that regulate fibroblast metabolism, including the balance between, once again, production of type 1 collagen and its breakdown by MMPs. Fibroblasts regulate the synthesis of collagen and other extracellular matrix proteins in response to mechanical tension, so they have to be always in tension, but it has to be like always stiff tension, or it shouldn't be too soft, it has to be normal. And when increased mechanical tension sort of stretches fibroblast, which coordinately increases collagen production and decreases collagenase production. Unfortunately, the converse situation is also true. When there is a collagen fragmentation that causes loss of attachment sites for the integrins and impairs the ability of collagen fibers to provide mechanical resistance against collagen fragmentation causes, once again, loss of attachment sites for integrins and impairs the ability of collagen fibers to provide mechanical resistance against cytoskeletal contractile forces. There is this kind of discoordination in between of inward and outward pull. And the fibroblasts, as you see here, collapse. They collapse. And thus the slow accumulation of cross-linked collagen fragments that occurs during the aging process compromises the structural integrity of the collagenous matrix and creates an environment in which fibroblasts lose mechanical tension or collapse and produce less collagen and more MMPs. So this is basically this is the process. That's how it goes. And here you may see once again it's a kind of not a kind of but electronic microscopy where you can see this abundant collagen when it's like absolutely when the situation when the this force is when the ECM remodeling it works fine, when the fibrils of collagen when it's like you see I'm pointing to the actual marks where it is connected to the fibroblast. So and the fibroblasts are nicely stretched, they're elongated, and the nucleus is like elongated well enough. But with the flow of time over the years, when they are broken, all right, this is when they are defragmented, they're broken, they lose because of the photoaging and chronological aging. They basically collapse. And as you may see here, they don't have any more connection between with the other cells, and they don't have connection with the ECM proteins. And this is basically how this process looks under the electronic microscopy. And once again, it's also another example of the ECM hydration here that I like to show you. So ECM hydration is quite important as well for the normal functioning, for the healthy functioning of ECM, and it is all related to the proper hydration and the presence of glycosaminoglycans and hyaluronic acid, just because it stimulates cells differentiation and migration. Without it, it just like doesn't occur. And on the A side, you see well hydrated ECM, and so it's a picture taken with the help of electronic microscopy, and B is basically dehydrated extracellular matrix. Now, one more time, I'd like to emphasize on UV light and how it affects badly in the normal skin aging. UV light promotes acute inflammation in the skin. So we, before that, we already mentioned that. So it actually promotes two types of inflammation. It promotes acute inflammation. So every time after, like, you know, we like spend some time under the sun, we have this, like, you know, immediately red skin, right? And this is when the skin is full of those MMPs and different kind of cytokines and so on and so forth. And then when we kind of like move in, when we already starting to have a tan, so this is more like a chronic inflammation. All right. So, and nevertheless, UV light promotes the inflammation in the skin, and then it promotes the activation and basically appearance of reactive oxygen species in the skin that can be also generated by some other factors, like not only the UV light, by pollution, and sometimes even by normal cellular metabolism when we run, overrun too much with, or possibly experiencing some other type of body stress. And when reactive oxygen species levels exceed the skin antioxidant defense capacity,